In this video, we learn to integrate side effects such as fetching data from an API in a React component. We'll discover the use of the component did mount and the component did update lifecycle methods when working with class components. So let's get started. Alright, in the last video, I asked you a question. Where would you perform side effects such as fetching data from an API in a class component? I'm sure you would have guessed the right answer by now. There are two kinds of side effects that we have to deal with. Those that do not require a cleanup, such as fetching data from an API using an HTTP request, and side effects that do require a cleanup, such as using timers or even WebSocket-based subscription services where you have to unsubscribe when the component is unmounted. The first and most common type of side effect involves placing a network request to an API or a service to fetch data that you would want to display in your React application. This kind of a side effect does not involve a persistent network connection such as the ones using WebSockets or subscriptions. Our app sends an HTTP request to an endpoint, and the API service responds back with a result, typically as a JSON object, which we can then consume in our React application. Therefore, after performing the side effect, we don't need to perform any cleanups or teardown to prevent memory leaks. On the other hand, we have side effects which do require cleanup. In this case, we subscribe to a service or a function when our application or component mounts. When our component unmounts, however, we need to unsubscribe from this data channel to prevent potential memory leaks. Handling both kinds of side effects is relatively simple. So first, let's tackle how we'll implement side effects which do not require any cleanup, such as fetching data from an external API. There are two places where we can perform such side effects in a class component. The component did mount function is the most obvious lifecycle method which allows us to perform side effects when the component is mounted for the first time. This way, you can fetch initial data to render. On the other hand, when your component is in the updating phase, such as when data in the props or state change, you can use the component did update method for implementing side effects. On the other hand, when your component is in the updating phase, such as when data in the props or state change, you can use the component did update method for implementing side effects. Let's begin our discussion with the component did mount function first. This function, as you would recall from the last video, is called after our component has been mounted into the DOM for the first time. You can then query an API to fetch data and update the state, which causes the component to update and display the results. You can also subscribe to WebSockets here and attach event listeners for data. For instance, this would be needed for an app that displays real-time stock market rates. It should also be noted that since this method runs after the component has been initially rendered into the DOM, it can also access DOM properties using references if needed. Let's look at an example of fetching data from an API. So go ahead, download the project starter files from this link and then extract and install dependencies. Here we are in our app.js file and I've got my development server up and running already. On the right, you can see the output of our app, which fetches and displays a joke from an external API. The joke itself consists of a setup and a punchline. The app also allows you to click on the title bar here to fetch a new joke from the API. At the moment, we are displaying a joke that I have hard-coded into the state, and this is passed down to the joke component using props, which just displays it in the area below the title bar. We also have a state property called isLoading, which is set by default to false. This is used to conditionally render a color animation effect on the title bar, indicating that we are fetching content from the API. The first thing we need here is a function that queries an API to fetch a new joke and populate the state. I'll thus build the getJoke function which will use async-await. Now before we actually query the API, let's set isLoading to true so that our title bar displays a pulsing color effect. I'll thus use this.setState like so. Now very quickly, let me demonstrate what this achieves. I'll add an onClick event listener on the title bar and we'll invoke the getJoke function. You'll notice the class name attribute is already using a ternary expression to switch CSS classes based on the value of the isLoading variable. When I click on the title bar now, you can see this color pulsing effect that indicates we are fetching data from the API. Next, we want to query an external joke API service. For doing so, we'll use the fetch API, which comes integrated in this development environment as a part of the pipeline that the Create React app provides. Using the fetch API, which returns a promise, we'll first query this URL, which returns a random joke as a JSON object. We'll then need to process the result as a JSON object, which is achieved using the built-in JSON function like so. This also returns a promise, hence the use of the await keyword. The outcome of this process is an object which resembles the joke object in our state. Therefore, to keep things simple, we'll set the entire thing into the joke state variable. And since our data loading process is now done, we'll set isLoading back to false to stop the color pulse effect on the title bar. I'll also clear out the test contents of the joke variable in the state. The next thing we need is a way to run the getJoke function when the component loads up. This is where we'll build our component.didMount function, which would just invoke the getJoke function like so. Once the application is rendered and in the DOM, the component.didMount function is immediately invoked, and this leads to setting the state with data fetched from the API. This causes the component to render again in the updating phase, and you get to see your content on the UI. You would have noticed the pulsing title bar indicating the fact that we are fetching data. Now, since we also rigged up the title bar to execute the getJoke function, you can click on it to refresh and get a new and random joke. As you saw in this example, with class components and side effects that do not require cleanup, you can use the component.didMount lifecycle method to perform API or network requests, among other things. Let's also see a situation where the class component depends on a prop for performing side effects. Begin by downloading, extracting, and installing dependencies for this project first. We are once again on the Joke Machine app, but with several changes this time. First up, our main app component is now a simple function component that renders the outer container, a drop-down menu for selecting the category of jokes, and an instance of the joke component. We are using the simple hooks API for storing one state variable called category, which serves as the value of a prop for the joke component. The joke component has been revised as well. The joke API that we are using in this example allows you to include one of two category keywords, general and programming, in the URL. Consequently, the component.didMount now passes the value of this.props.category to the getJoke function when the component is initialized for the first time. The result of our API call in this case returns an array from which we are using the first and only object to display the joke. In a way, the joke component is now self-sufficient and reusable. The only thing it needs to work is a prop named category, which should be set to either general or programming as the flavor of the joke being fetched. Now, when you load the app and the joke component instance is created for the first time, it gets the value of the category prop as general from the app component, and the component.didMount function runs, fetching the joke for us. But what happens when I change the category now? You'll notice that nothing happens when I change the category. In fact, behind the scenes, whenever I change the category and the category state variable in the app component is changed, the app component re-renders, causing the joke component to re-render as well. What is important to understand here is that this re-render occurs as part of the updating phase and not the mounting phase, because the component is already in the DOM and mounted. This also means that while the component is updating, the component.didMount function, which is responsible for executing the getJoke function, isn't going to be invoked, since it is only invoked when the component is first created and mounted in the DOM. We thus need a solution which allows us to run side effects in the updating phase of the component. And the answer to that is the component.didUpdate lifecycle method. When implementing the component.didUpdate method, you get access to the previous value of the props as well as the state. This is great because it lets us check if the new value in the props or state is in fact different from the one being used previously. We should only be querying the database if the value in the prop differs from what it was previously. While this may seem like a tiny optimization, the downside of not implementing a conditional check here is that every time the component updates, the component did update function will fire, causing the getJoke function to be executed, which will set the state, causing yet another re-render, and this goes on and on and on and on until your browser locks up and crashes. To avoid getting into this infinite loop, we only want to fetch new data if the value in the prop changes. So we'll check to see if this.props.category is indeed different from previous props.category. If so, we'll run the getJoke function passing in this.props.category, which brings in the freshly changed value in the prop. And this gets the job done. In this video, we examined side effects that do not require cleanup from the point of view of class components. We saw how component did mount and component did update functions can be used for implementing network requests for fetching data from third-party APIs. While the examples we saw involved class components, function components do get to play with somewhat similar abilities using the hooks API. In the next video, we'll take a look at an example of implementing a timer in a class component. Timers involve side effects which require cleanup to avoid memory leaks. Let's examine this case.